What if the most powerful telescope ever built has revealed something we were never supposed to see? What if everything we thought we understood about the origin of the universe, about time, space, and reality itself, is starting to fall apart under new evidence? The James Webb Space Telescope, designed to observe the earliest light in the cosmos, has produced data that many scientists find deeply puzzling. Some researchers argue that what it is showing us may challenge the very foundation of modern cosmology. In a distant region of the sky filled with ancient light, the telescope detected a faint glowing object that at first looked ordinary. But closer analysis revealed something extraordinary. It wasn't just another distant galaxy. It appeared to be one of the most faraway galaxies ever observed, existing only a few 100 million years after the early universe is believed to have begun. The problem is that it looks far too advanced. It appears too massive, too bright, and too structured to have formed in such a short cosmic time. According to current models, there simply shouldn't have been enough time for such complex galaxies to exist so early. And this isn't an isolated case. More similar objects have been found, each one raising the same question: how could something so developed appear so early in cosmic history? Some of these distant galaxies also seem unusual in another way. Instead of containing a mix of gas, dust, and stars like typical galaxies, a few appear to be almost entirely made of stars. This goes against standard expectations of how galaxies form and evolve. These findings have led some scientists to question whether what we are seeing is fully explained by current theories. If the models are correct, these observations shouldn't exist in their current form. Yet the data is there. This has sparked deeper questions about the limits of what we can observe. Because of the expansion of space, there is a boundary known as the observable universe. Beyond it, there are regions that light has never had time to reach us from. And yet, telescopes are still detecting signals that challenge our understanding of these limits. This raises a difficult idea. Are we truly seeing the early universe as it was, or is something more complex happening that we do not yet understand? Some researchers even suggest that our picture of the early universe might be incomplete. If galaxies formed faster than expected, or if light is behaving in ways we do not fully understand, then the timeline of cosmic history may need revision. In addition to these distant structures, subtle patterns have been detected in cosmic background signals. Some of these patterns do not match known natural sources like pulsars or gravitational waves. They appear in repeating intervals, almost like a structured signal, though there is no confirmation of any artificial origin. At the same time, measurements of gravity at extreme distances have shown unexpected effects. Some regions appear to be influenced by unseen mass, creating distortions in space that cannot be easily explained by visible matter alone. This is often discussed in relation to dark matter, but even that does not fully resolve the mystery in every case. These anomalies have led some theoretical ideas to resurface, including the possibility that our universe might be part of a larger structure or that other cosmic regions could be influencing what we observe. These ideas remain speculative and are not confirmed by mainstream science, but they reflect the level of uncertainty now being discussed. There are also observations of unusual asymmetries in the rotation and movement of distant galaxies. In some cases, patterns appear inconsistent with standard expectations, suggesting that something about large-scale structure formation may still be missing from our understanding. In another set of observations, light from extremely distant sources has shown unexpected behavior. Instead of fading as expected, some signals appear to reappear with similar characteristics, raising questions about reflection. All of these findings come from a telescope built to answer one of humanity's biggest questions: how did the universe begin? Instead, it is revealing more questions than answers. Each new observation adds complexity rather than clarity. The early universe may not be as simple or as well understood as once believed. And with every new dataset, scientists are forced to reconsider how much of cosmic history is truly known. Whether these results point to new physics, gaps in current models, or something entirely unexpected remains unknown. What is clear is that the universe is proving to be far more complex than previously imagined. And as research continues, one question becomes harder to avoid. Are we truly seeing the full story of the cosmos, or only a fraction of a much larger reality we have yet to understand? As researchers continue to analyze the data from the James Webb Space Telescope, a pattern is beginning to emerge. Not a clear answer, but a deeper mystery, one that suggests our current understanding of the universe may be incomplete rather than entirely wrong. One of the first things scientists revisited was the timeline of the Big Bang. For decades, it has been the backbone of cosmology, supported by observations like the cosmic microwave background and the expansion of space. But the newly observed early galaxies are forcing scientists to rethink how quickly structure could form after that event. Instead of discarding the Big Bang entirely, many researchers now believe that something important is missing from the picture, perhaps unknown processes that accelerated galaxy formation, or conditions in the early universe that were far more extreme than current models assume. Another key concept under scrutiny is the Hubble sphere. While it is often misunderstood as a hard edge, it is actually a dynamic boundary shaped by the expansion of space. Light from beyond it can still reach us under certain conditions. This means that some of the impossible observations may not be violations of physics, but rather signs that our intuition about cosmic distances needs refinement. The idea that we are seeing beyond the universe is not supported by evidence. What we are seeing is still part of our observable universe, just at extreme distances and times that stretch our current theories. As for the unusual galaxies that appear to contain only stars, scientists are considering more grounded explanations. These could be systems where gas is present but difficult to detect, or galaxies undergoing intense bursts of star formation that temporarily make them look different from what we expect. Observational limits and interpretation challenges also play a role. The so-called heartbeat signal, or repeating cosmic frequency, has not been confirmed as anything mysterious or artificial. In many cases, such patterns turn out to be instrument noise, data processing artifacts, or natural astrophysical phenomena that are not yet fully categorized. Extraordinary claims require extraordinary evidence, and so far, no verified signal suggests anything beyond known physics. Similarly, the idea of phantom mass, or unseen gravitational effects, is closely related to the well-established concept of dark matter. While dark matter itself remains one of the biggest unsolved problems in physics, it is not evidence of another universe. It is an active area of research within our own. Theories about mirror universes or time-reversed realities do exist in physics, but they are highly speculative and not confirmed by current observations. The data from Webb does not provide direct evidence for such ideas. At most, it highlights gaps in our understanding of how galaxies evolve and how matter behaves under extreme conditions. The observation of light appearing to return or behave unexpectedly can often be explained through known effects such as gravitational lensing, where massive objects bend light and create multiple images, or the curvature of space itself. These are fascinating phenomena, but they do not imply a boundary or surface at the edge of the universe.